Border safety in Europe is an evolving challenge. While authorities work hard to keep a virtual eye on things, there are new threats every day. These require new technologies to overcome. For example, current maritime surveillance equipment can easily scan the airspace above and the surface of the water, but there is an area between these two extremes that is invisible to radar. This open area could become a haven for criminals delivering their contraband via low-flying planes, helicopters, or even unmanned drones. With limited resources, authorities are committed to curtailing this kind of coastal criminal activity, but something more is needed. The European Commission responded to this need several years ago and assembled the ALFA team. Using the powerful combination of knowledge and technology, the ALFA project employs 9 partners from 6 countries. Their charge? Augment existing radar equipment to detect aircraft in the clutter zone. The team has been developing specialized technology for the last 3 years. Until now, it's been theoretical and only tested as individual components. But here in Castelo Vela, Portugal, the team gathers for the first time to test everything together. Under the guidance of Rob van Heijsten from TNO in the Netherlands, partners converge to assemble their system, check results, and even celebrate achievements. But what are they actually doing?
What we do here is first integrating all systems together, making them cooperating with each other. As you know, we all do the work at home in our own laboratories, and this is the first time that we bring all the equipment together, connect all the systems together and see whether it works or not. And that's what we're doing. Of course, you need then a part of fine-tuning. Some small issues have to be solved, and after that we hope to have a working system. And as we have the working systems, we are able to test the system. For that we fly in helicopters, aircraft, drones, and we see whether we are able to detect them, but also to classify them in a proper way so that the operator on the screen knows this is a drone, this is a helicopter, and this is an airplane. What we then do next is we do behavior analysis, because there are also normal planes, normal drones, a lot of people are playing with it. So then based on the behavior of the drone or the aircraft or whatever it is, based on that behavior we say, well, this is suspicious, and when it is suspicious it gets additional attention, and that's all done by software and automatic equipment. And then we are tracking it with more precision and see where this system is going, and see whether we can predict the landing site where it probably will land. The setup of the control center is roughly about 15 people. What you see inside is first, of course, the radar screen. The radar is the primary sensor detecting an aircraft. When the radar decides this could be a drone or an aircraft, or it is flying in a suspicious trajectory, we say, well, this track is of more interest to us. Then the second screen comes into play. That's the camera. We can direct the camera towards the suspicious aircraft, have a look at it, measure the size, the height with more resolution than we can do with the radar. Then the third is, and that's a little bit difficult to explain system, that's what we call the passive RF. That is a system that can trace down systems based on their emissions from, like, the cell phone or any other electronic device that is on board of the aircraft. So the criminals don't see anything of a radar or a camera system, but we still can detect them. Then a fourth stage, we don't have a specific screen for that, but we have a processing system for that, is we combine all the three information of all the three, and based on that combined information we do what we call a threat analysis, and we estimate how suspicious the aircraft is. When it passes a given threshold, then we decide to do more analysis on it, and we start to do the landing site prediction on that, so that the police can be there before the criminals get there, and that gives them the ability to stop the criminals right in their track.
But how exactly does landing prediction work? ALFA partners worked closely with coastal authorities to record common trafficking patterns based on past interceptions to establish some probabilities. These stats, combined with the type of aircraft, topographical maps, and weather conditions, are fed into computers, and using custom algorithms, the data is processed to create landing prediction sites. The big benefit of ALFA is largely realized by the Portuguese National Republican Guard, or the GNR. They are one of the end users in this project.
GNR is a security force with a military nature, and it is constituted by military elements organized in a special body of troops. The Coastal Control Unit, what is this? It's a special unit that we have that has a main mission of monitoring, patrolling our coast and detect illegal activities. And also it's responsible for operate and manage our national surveillance system that is called CIVIC, the Integrated Command and Control System. It was developed to detect and to identify and to make the follow-up of small boats, more or less with 4 meters. A couple of situations regarding low-flying aircrafts that are non-authorized to fly, and also we have the case that we have knowledge that a flight from a helicopter that departed from south of Portugal, and then 2 days after he was seized in Spain with 400 kilos of hashish. Having ALFA system that will increase our reaction capability, because our national surveillance system has, well, it is working very well, quite well, but we could say that it has more or less a gap because we are not able to detect aerial threats, okay? And having a kind of a tool like ALFA, we will increase our reaction capability regarding cross-border crime, and especially this kind of modus operandi that drug dealers are using nowadays.
After 3 days of hard work, testing, adjusting, calibrating, and resetting, the team reviews the results.
I think one of the nicest things to see was the classification, because at the end of the day when we spoke to GNR, for them it was like easy, it was acquired, they've seen it works.
Yeah.
And for me that was a good satisfaction. I wouldn't like them to think it's too easy because it was a lot of work, but at least it worked.
It worked, and what I think is very important, and that was GNR was telling me, they said, well, this is a great system. What we had and we never had before is that you pointed this to a landing site, only this small complaint, the landing site is still too big. So we should have more work on it, which unfortunately we cannot do it in the project, but there is more work needed to confine that landing site.
Yeah.
But I think the great thing is that we showed that the concept worked and that we can deliver all the data that is needed to provide information for that landing site.
Excellent.
So we had the whole chain working, and I think that was a great achievement of this day, of this trial this week.
The successes reverberate throughout the team, and overall partners feel that they have achieved their goals.
We saw quite some success the last 2 days. We have seen small aircraft, drones being detected, being followed, being predicted where they're going to land. That's exactly the message ALFA was giving 3 years ago when we started out this project. It brings together a lot of different European experts. They work together heavily the last couple of years, and what we see now is the success of the system. We can predict landing zones, we can distinguish, the birds are filtered out, so the authorities can really focus on what they're looking for, which is possibilities of drug smuggling or other stuff. And this can be extended in the future.
Safety along the borders of Europe is an important issue and one that changes rapidly. Projects like ALFA prove that the collective efforts of many European nations is the best strategy for getting things done. ALFA will evolve through the years, But for today, we can relish in the past achievements and expect a safer tomorrow.